Alright, the Railway Education Bureau. Stop, think, study, glares, the road to progress. Instruction paper unit number 22A, subject diesel locomotive operation. Power plants, Alco, American Locomotive Company, GE 660 and 1,000 horsepower diesel locomotives, copyrighted 1948 by DC Buell. Power plants, Alco, GE 600 1,000 horsepower diesel locomotives. Figure 1, Figure 2, Figure 3, Figure 4, 5, and 6. Diesel locomotive operation, power plants, Alco, GE 660 1,000 horsepower diesel locomotive, general. American Locomotive Company manufactures 600 horsepower, 1,000 horsepower switching locomotive road switchers of 1,000 horsepower. It also manufactures regular diesel railroad locomotives at 15 to 2,000 horsepower for both freight and passenger service. These units can be used with multiple combinations as desired. Figure 1 illustrates a 660 horsepower switcher. Figure 2 illustrates a 1,000 horsepower switcher. Figure 3 illustrates a road switcher. Figure 4 illustrates a single unit 2,000 horsepower road locomotive. Figure 5, 2 unit 4,000 horsepower road locomotive. Two of the 2,000 horsepower locomotives are coupled end to end, shown in Figure 6 to make one 4,000 horsepower double-ended locomotive. With the road locomotives are same for either freight, passenger service, except for the possible change in gear ratio, driving motors. The electrical equipment for the various locomotives is manufactured General Electric Company. To the power plant of the 1,000 horsepower switcher will be described with the difference between the power plant of the switcher and that of the 660 horsepower switcher, as well as the difference of power plants, road switchers, and regular road locomotives will be pointed out. Figure 3, the power plant of a 1,000 horsepower switcher is described because of the crew of the switcher usually is responsible for the operation power plant auxiliary equipment as well as the operational locomotive itself. Okay, 1 engineer seat, 2 control stand, 3 fireman seat, 4 door, 5 diesel engine, 6 generator, 7 turbocharger, 8 auxiliary, 8 air compressor, 9 combined air auxiliary generator exciter, 10 blower for the rear traction motors, 11 blower for the front traction motors, 12 cooling fan, 13 door to engine compartment, 14 water selections for the radiator, 15 oil section radiator, AAA mechanical throttle linkage, B engine governor. Alright, 4. Figure 7 shows a floor plan, cutaway switch, as side view, 1,000 horsepower switcher. Illustrated in Figure 2, the arrangement of the name of the principal parts are shown. The arrangement of the road switcher is much the same as that of the regular 1,000 horsepower switcher, except for the extension on the back of the cab. Figure 3 provides a space for the steam generator. There is provisions also for coupling 2 of the road switchers together, operating in 2 units for the control station of either cab. Figure 8 is a floor plan which shows the arrangement of the cab engine single unit road locomotives, illustrated in Figure 4. Power plant of 1,000 horsepower switcher, illustrated in Figure 9 and 10. The power plant is placed inside of the engine, shown in Figure 9. Is at the left side of the locomotive side, shown in Figure 10. At the right side of the locomotive, certain parts of the engine are numbered and named in the figures. 8. The diesel engine has 6-cylinder, operates on a 4-stroke cycle principle. For the bore of the cylinder is 12.5 inches. The stroke of the pistons is 13 inches. Normal operating speed is 740 horsepower revolutions per minute. Engine is directly connected with the directly current generator by a solid coupling. The 660 horsepower switcher has an engine exactly the same type, but without the turbocharger with a small generator. The power plants of the road locomotives are the same as the power plant for the 1,000 horsepower switcher, with the addition of the necessary electrical equipment for the. And it shows a picture of the engine. throttle linkage, governor, solenoid shutdown valve, Bosch fuel oil injection, D fuel oil plunger pump, return drip pan from fuel oil injector nozzle, plunger pump cutout and pin handles and fingers, G engine shutdown lever, H float fuel plunger pump reset lever, I drip box, I main drip box, J lubricating oil filler opening, K lubricating oil bayonet gauge, L header of fuel oil plunger pumps, M water pump, N Bosch injection assembly drive shaft, O turbocharged exhaust manual folds, P Q engine cooling water header, R lubricating oil pump, S lubricating oil pump pressure stop switch, T air inlet manifold, U generator. Alright, remote control engines from all the cab. The new type of the V engine has been designed for the roads which run locomotive. Principal operation 9 has been stayed with a diesel engine with a design to operate with a 4-stroke cycle principle. Operation is practical with the same as well with a gasoline engine, except that air only is emitted above the piston during the first emission stroke. During the second compression stroke, the charge of the air is compressed to about 450 pounds per square inch. Much higher pressure than necessary with a gasoline engine. When the piston nears the top of the second with the compression stroke, the charge of the fuel oil is sprayed and pressure into the charge of the compressed air with the temperature of the highly compressed air is about 1,000 degrees. This is high enough to ignite the fuel oil as it is sprayed into the cylinder. No spark is necessary. Burning over the fuel with the consequently explosive expansions of the fuel and air into the cylinder causes the third power stroke of the piston. On the fourth exhaust stroke, the burned gases are expelled from the cylinder through the exhaust valve. 10. When the supercharger issues the air under the pressure is forced for the turbocharger into the cylinder during the exhaust stroke, that helps to clear scavenging of the cylinder of the exhaust gases. Then emission stroke with the charge of the air pressure of the power stroke is forced the cylinder under the pressure from the turbocharger. This great amount of the air is compressed into the cylinder thus, and then it's possible when ordinarily emission valves arrangement. 11. The amount of fuel which can be burned on any firing stroke is limited to the amount of air which can be compressed in the cylinder. The additional amount of the air compressed in the cylinder used as a turbocharger allows more fuel to be burned on each firing stroke with the counts to increase the power of the engine equipped with the turbocharger, although there is no increase the size of the cylinder or the speed of the engine. 12. The power that drives the diesel locomotive is developed one or more diesel engine mounted on the bed or framework of the locomotive. No practical mechanical device has been developed to transmit the power from the crankshaft of the diesel engine directly to the driving wheels of the large locomotive. That is, device such as the clutch and transmission used in the automobile is not practical. Large sizes for starting and accelerating very heavy loads. Desired flexible for the control of the power developed by the diesel engine is obtained by the use of electric transmission. 13. The power is transmitted electrically from the crankshaft of the engine over the wheels of the diesel electric locomotive. Mechanical engine delivered from the crankshaft of the engine is converted to electric energy by means of the direct current generator. The electrical engine is delivered from the generator to the traction motor, which are mounted on the trucks of the locomotive and are connected with the driving wheels by the means of the reduction of gears. 14. The engineer of the diesel locomotive means with the cab throttle increase the decrease of the power output of the diesel engine. Each movement of the throttle away from the idling position result with a corresponding increased amount of fuel oil supplied to the cylinders of the diesel engine, consequently increases the speed of the power output of the engine. 15. Variation electrical power supplied by the generator traction motor is accomplished by a combination of manual electrically control. The combination of controls make it possible greater flexibility with the transmission power of the diesel engine to drive the wheels of the locomotive operating the power plant. Figure 11 is a view of the engineering position cab of the 1,000 horsepower diesel switcher. Names of the part are shown. Figure 12 of the view is of the corner of the cab. The right of the view shows in Figure 11. And Figure 12 shows the handle of the battery switch. K, the emergency fuel oil cutoff pull knob. M, and the fan shutter operating lever. N, none of the which are visible in Figure 11. The valves of the lower right hand in Figure 12. A reducing valve, V valve, the air brake system, the door J are shown in both figures 11 and 12, opens into the electrical apparatus cabinet. Figures 17, instruction and the text will be presented under the following 6 general headings. Preliminary checkup required before starting the engine. Starting the warm-up of the engine. Checking the engine will not turn over. 4. Check if the engine turns over but fails to fire. 5. Moving and stopping of the locomotive. 6. Shutting down the power plant. 18. Locomotive crew call for the duty. One of these switchers may encounter one of the 3 conditions. First, locomotive may be standing after the number of hours of shutdown. Second, the locomotive may have been serviced by a roundhouse force and the engine may be running or warmed up. Third, one crew may be simply reviewed and another crew, in which case the engine will be running. 19. If the locomotive has been serviced, engine is running when the new crew takes charge about. But the only checkup is necessary to inspect the fuel, oil gauge, water glass expansion tank for the cooling system, and the bayonet gauge, which show the height of the lubricating oil crankcase of the engine. The gauges of the indicator for the instrument panel should be checked to see if the proper air pressure for the operation and brakes of the control to see if the storage and battery is charging. Fuel pressure gauge should be about 35 pounds. Lubricating oil gauge should be between 35 to 45 pounds. The temperature for the cooling water should be between 150 and 170 degrees. 20. The new crew of the course is responsible for knowing that their power supply, flag, and even the equipment of the locomotive includes the proper signaling equipment according with the rules of the road, against the rules to carry the waste on diesel locomotive other than oil-soaked oil waste, so the repacking the axle bearings lint from the wiping waste is likely to clog up the oil lines, interfere with the proper working electrical equipment. Wiping rags are furnished for the use of the diesel locomotive, and supply should be on the hand of the locomotive. 21. With the crew arrive at the locomotive, which has been standing for shutdown for several of the hours, thorough the systematic checkup should be made. Such a checkup is described in the following paragraphs. Preliminary checkup of the power plant. 22. Necessary preliminary checks before starting the diesel engine are as follows. Check to see if the emergency fuel oil valve is open. Check the fuel oil supply. Check the cooling water supply. Check the lubricating oil supply. Check anything loose under repair if the engine compartment, and check the position of all shutters. G. Check the fuse panel to make sure that all fuses are in place. Each of these items are discussed separately. 23. Check position emergency fuel oil valve, fuel oil tank underneath the floor of the cab. The pipe that leads to the tank toward the fuel pump. The emergency fuel oil valve is located with the pipe between the tank with the fuel pump. It can be inspected by opening of the door electrical cabinet when the valve is open and the stem of the valve is in the upper position and the latch. When closed, the unlatch and down. This valve must be open, and otherwise oil cannot flow from the fuel oil tank to the fuel pump. 24. As well, before climbing up the locomotive, check for the angle cocks end of the brake pipe of the locomotive to see that they are closed. The main reservoir drain valves should be checked also to see that they are closed. There are other valves which must be checked later in connection with the checkup of the lubricating oil and cooling system. 25. Check the fuel oil supply on switcher of the gauge that indicates the amount of the fuel oil main fuel tank located inside the small door directly below the engineer's window outside of the back of the cab. The gauge is likely old-fashioned water gauge glass on a boiler. The first inspection of fuel oil system is to check with the sight glass gauge, but the operator can decide whether there is sufficient fuel for a trick or run something. Sometimes very clear grade of white fuel oil is used. Close to the inspection may be necessary to determine the height of the switch fuel oil in the glass filler pipe, usually located outside of the door. 26. The fuel oil tank of the locomotive, when filled with a whole 635 gallons, fuel oil is added to the tank throughout with the filler pipe as just mentioned, indicating the site. So we have the nozzle drain, nozzle delivery pipe, fuel pump, pump housing, gauge and cab box, fuel header, fuel filters, regulating valve, motors, diesel, strainer, relief valve, 75 pounds, trip, emergency cutoff, trip knob, vent and fuel tank, fueling pipe, sump, drain, and cap. Glass gauge will show the approach of the oil top of the tank. This is vent pipe, top of the tank. The vent pipe contains flame arrestor. The fuel oil circuit shown in Figure 13. This sketch is known as the schematic diagram that is shows the various parts of the pipes without making much reference to the piping detail with the actual size, the location of each of the part. There's a sump at the bottom of the fuel oil tank in which the water, dirt, and sludge can sink. There is a drain valve below the sump. The drain pipe is capped. To prevent loss of fuel, should unauthorized person open the valve of the cab to be removed with the pipe at the range for the sump to be clear of the water if the fuel system is to be drained. 28. The pipe leads for the near of the bottom of the fuel oil tank through the duplex drain with the emergency cutoff valve of the main fuel oil pump. Pump is driven by its own motive. The pump is operating of the fuel oil with the force under the pressure path of the relief valve through the additional filter fuel header of the Bosch fuel injection assembly side of the engine. Figure L, Figure 9, the small powerful plunger pump D. Each of the cylinder is an assembly of the plunger of the pump. Each injector forces charge of fuel oil through the injector nozzle into the cylinder at the proper time for each power stroke of the piston of the cylinder. 29, referring to again to Figure 13, where there is a return line from the fuel header of the Bosch injection assembled to the fuel tank. There is a 35-pound regulating valve within the cylinder. The valve also acts with the vent air with the roof of the system. The fuel gauge of the cap is connected into the line between the fuel header with the regulating valve. The regulating valve is set with normally at 35 pounds. So the pump is designated with the supply of the surplus oil to the header of the fuel oil will keep the regulating valve with the unseated its flow over the back end of the tank. The fuel gauge in the cab indicates setting of the valve. The 75-pound relief valve near the pump has a pipe from it. It's in discharge port to the fuel tank. 30 moving parts of the plunger and pump, injection nozzle, boss injection assembly, lubricated with bar of the fuel oil with the passage with the assembly. Fuel oil seeped in the pass. Each of the nozzle spindle is piped into the open box receptacle on the side of the engine. There are 3 boxes. One can be seen at I in figure 9. Each box received with a drain. 2 with a 2 nozzle with the 3 boxes with in turn drain into the main drain box I1 figure 9. Only the main drain box indicated in figure 13. Another drain pipe leads from the plunger pump suction boss assembly to the main drain box. The main drain box directly into the fuel oil tank. 31 leads with the drip pipe from any of the nozzle spindles should not be more than a couple of drops a minute more than may indicate with the dirt under the seat of the valve of the injector. Nozzle excessive wear of the needle plunger or some other condition that should be reported to the maintainer. Again, if there's no drip at all, one or more of these pipes, it indicates a lack of the proper lubrication at the injector. Should such a case be discovered, the injector can be cut out by releasing the shot pin corresponding plunger pump. Under no circumstance must any of the drain lines be plugged. 32. There is a cutout pin with a base each of the plunger pump of the boss injection assembly F figure 9. If the pump is pulled out with the turn and released while the engine is running, it will cut out the pump and shut the fuel off the fuel injection corresponding cylinder. These pins must be latched properly, but the corresponding pump will not operate. At 33, if the shutdown lever of the G figure 9 alongside of the plunger pump can be operated by hand or automatically, overspeed safety device shut down all these plunger pumps to stop the engine. In case of shutdown, each stop pin must be pulled out, latched by hand before the engine can be restarted. Resetting requires 2 operations. First, the pins must be pulled out and turned until the finger over each of the pin rests on the top of the cutout rack. This is so that the spring will not pull on the pin back, and again when all pins have been given the first adjustment with the reset lever is pulled out. With this in turn move the cutout rack to the starting position. Any cutout pin finger does not slip into the proper notch. Cutout pin handle must be turned again with the proper position. The handles of the pins close the vertical of the overspeed trip will not function again after it has tripped until the reset lever has been pulled out and the pins have been properly reset. The pins are not properly reset until each finger is in the proper notch. 34. Usually there is a bleeder above the plunger of each of the oil pump of the Bosch injection assembly. Second bleeder each injector nozzle. The air gets into the fuel oil pipes leading the fuel injector. These bleeders may have the opening of the engine will have to be cranked means of the battery to clear the pipes of the air. No fuel reaches the cylinders of the engine will not fire until this has been done. In case where there is may be necessary, it was when main fuel tank has run dry and then is refilled. 35. The fuel oil filtered once before it reaches the main fuel pump. Again, before it reaches the fuel header of the Bosch injection assembly filter. But again, with each injector filter with a different type of the duplex filter, 3-position handle so that the oil can be directed first to the one side of the filter. Then, when it becomes dirty, the other side of it, which should be clean. The duplex filter handle is kept at the mid position. Both sides become dirty at the same time. Thus, the advantage to have the clean filter is reserve is lost. Some other types of filters, other types of filters, clean handles should be turned every few hours in order to scrape the accumulated sludge of the filtering surfaces for the filters are serviced by terminal forces. 36. The emergency fuel oil cutoff valve. The name of the implied with the emergency oil shut off the oil for the supply closes the fuel tank in case of the accident and danger of the fire that can be operated with the pulling an emergency knob within the cab similar knob located on the running board ahead of the cab on either side of the locomotive. If the emergency fuel oil cutoff valve has been tripped, it may be reset by pulling up the stem and adjusting the latch to hold the stem up. 37. There are 2 tanks of the road switcher. One tank is used for the water source of the road switcher of the clip of the steam chamber. There is no steam with the generator or valve of the pipe which connect to the tanks that can be opened with both tanks used with the fuel oil. Regular fuel oil tank road switcher under the floor of the cab. The gauge glass for the filler pipe with the air over the right over the side of the locomotive. Second tank with is under the bed of the locomotive between the trucks. It also has the gauge glass of the filler pipe which can be reached from the right over the side of the locomotive. Road switchers also have the two remote gauges and cab switches shown in the amount of the liquid in these two tanks. 38. Checking the engine cooling water supply. Figure 14. Schematic diagram. Engine cooling system with 1,000 horsepower. Switcher of the water simply circulates around and around. It's heated as it passes through the engine block and cooled as it passes through the radiator of the expansion tank at the top of the engine compartment just back of the radiators. This expansion tank takes care of the fluctuation in height of the water, but the temperature of the water changes. The system should be filled so that the water is within an inch or an inch and a half of the top of the expansion tank shown by the water glass on the tank. The back of the engine cooling water is followed with the water from the expansion tank. Keep the radiators full with the water from the bottom of the radiator flow to the roof of the return line engine block through a passage inside the engine block to the water pump. M. Figure 9. Water pump is driven by the gears from crankshaft of the engine. The pump forces the water under the pressure around the cylinder and heads out of the engine with the water. After cooling, the engine is discharged from the water header at the top of the cylinders to the pipe which leaves the radiator. This pipe is branched to the expansion tank. 40. The thermometer on the instrument thermometer of the instrument panel is the cap connected to the water header, consequently indicating the temperature of the water after it's been circulated through the cooling space of the engine. 41. The cooling water system have the connection with the water pump with the turbocharger. See Figure 9. The turbocharger is driven exhaust gases from the engine with the gas turbine. When the end of the turbocharger has to be cooled. Water which flows for the cooling of the passage of the turbocharger is piped back to the engine block. Flows of the cooling water through the engine and cooling spaces. 42. There is a pipe with the water header that leads through the cab heater with the back through the return line, the suction side with the water pump. There are the drain lines, valves, the cooling cavities of the turbocharger can be drained. So that the cooling cavity of the engine block can be drained. These drains or valves must be closed when the engine is running. The cab heater is cut in the drain line as well with the radiator of the expansion tank. All other parts of the cooling system can be filled by connecting a hose at the drain line with the running water into the opening of the expansion tank of the roof of the engine hood. 43. The fan over the roof of the hood of the exhaust air of the engine compartment of the cooling air will drawn from the road through the radiator shutter to the regulator. The amount of air exhausted by this fan can be adjusted. Means the shutter operating lever in cab. There's a hand operated shutter outside each of the radiator adjust the running board by loosening a wing nut. Move the lever, give the opening desired, but the wing nut must be tightened after the adjusting is made. The combined adjustment of the shutter for the radiators and shutters are at the fans. Shows cap vent filling pipe at the roof of the radiator, shutter control water oil, shutter control water radiators, return line, expansion water glass cab, water heater cable, thermometer, and cab. Water suction passes inside the block, supercharger, cab heater, engine block drain, water pump drain from water pump packing, cab heater, return pipeline, supercharger drain, overflow vent, and drain and filling pipe. Figure 14 should enable the operator to keep the cooling water temperature between 150 to 170 degrees in all kinds of weather. In warm weather, the shutter and oil section of the radiator should be kept open, and the other shutters adjusted as necessary to maintain the desired temperature of the cold weather. The shutter of the oil section kept shut and an adjustment made with the other shutters. 44. Several sections at the rear of the radiator right side of the locomotive are used to cool the lubricating oil shutter, and the oil section of the radiator should be kept closed except for the warm weather and cold weather oil switch which passes through these sections will become chilled if the shutter is left open. This might make the oil stiff and it would be not circulate through the radiator properly. 45. On road switch and provision of other circulation over the water engine block to keep the water from freezing during cold weather. Consequently, the locomotive stand out over the doors of the engine must be kept running continuously, or else the cooling water must be drained properly from all parts of the cooling system. This includes the engine block, turbocharger, the cab heater, as well as the radiators. Engine man should learn the position of the different valve of the water cooling system on the locomotive. They are operating so that the engine cooling of the system can be drained properly to prevent freeze up in the case of emergency shutdown cold weather. 46. Check engine lubricating oil supply. Lubricating oil with lubrication over the engine with a supercharger carried with the crankcase of the diesel engine. Height of the oil crankcase is measured with the means of the bayonet gauge. Okay, figure 9. The gauge like with the measuring of the oil in the crankcase for the automobile engine when the crank holds to 85 gallons of oil with the system filled with the proper height. This height is indicated with the mark on the bayonet gauge. Height of the oil crankcase should be examined before the starting of the engine. The oil should be brought to the proper level. The necessary oil is added to the crankcase, filling the hole which can be seen as J figure 9, 47. After the engine has started, the has run for the few minutes, the gauge should be about an inch less than the oil before this would cover the certain numbers of the gallons circulate through the system. When the engine is shut down, when the oil drains back into the crankcase, figure 48, figure 15, schematic diagram, a lubricating oil system oil supply shown in the crankcase, lubricating oil pump, located at the base of the engine, end of the opposite generator. CR figure 9, the pump is driven by gear of the crankshaft. The pump forces oil down from the crankcase through the pipe of the top of the cooling tubes. Oil units of the radiator is cooled and passed down through the tubes of these units. The travels of the bottoms of the units radiator back to the engine and passes through the Kuno oil strainers on its way back to the engine. So we have oil filter, water radiators, radiator shutter control, oil emergency bypass valve at 15 pounds, check type valve, relief valve at 35 pounds, regulating valve at 35 pounds, relief valve 75 pounds, pump, Kuno strainer, pressure gauge, pressure switch, wire, negative, positive wire, fuel pump, button filling hole, pipes to bearings, oil header, drain cap, governor, shutdown, solenoid, oil, supercharger, bearing, supercharger. 49. At the end of the lubricating oil forced through the various pipe of the patch to lubricate with the crankshaft piston, other engine bearings, branch pipe, lever the turbocharger, shaft bearings, pressure, lubricated engine, lubricating system, drive shaft, cam of the Bosch injection assembly. Oil from the various engine of the bearings drain back for the oil reserve at the bottom of the crankcase. 50. Referring again to figure 15 there at 75 pounds, relief of the oil pump of the pipe leads to the relief valve back to the crankcase. Relief valve operates the lubricating oil pump line. Lubricate becomes closed if any of the reason. Oil from the pump is forced from the tubes of the radiator. When cooled, it will be returned to the engine pipe of the distributor with the bearings. Normally, with the pipeline with the pump of the radiator back to the engine carries about 35 pounds of pressure for the radiator. Emergency bypass valve located off the pipeline is set at 15 pounds. The oil tubes in the radiator should be clogged in cold days so the oil cannot pass through freely with the pressure would accumulate with the pipe between the pump and the top of the radiator, which occurs when that there would be a light pressure of the pipe between the bottom of the radiator to the engine, with the differential of 15 pounds between the pressure at the top of the radiator and the bottom of the radiator emergency bypass valve will open. Radiator emergency bypass valve never opened during the normal operation of lubricating oil system. 51. There are 35-pound regulating valve in the pipe at the bottom of the oil radiator to the engine. The purpose of the regulating valve prevents excess of the overpressure in the line that indicates the problem of the supply with more than oil pressure necessary for the cave of the Kuno filters become clogged. Relief line with the regulating valve leads directly to oil space at the bottom of the engine crankcase. 52. Usually lubricating oil pump delivers the surplus oil more than required to force through the oil patch of the engine. When the pressure oil of the oil line sees the 35-pound with 35-pound regulating valve bypass with the part of the surplus oil back to the crankcase. Additional surplus oil passes through the check type of relief valve, which is also set at 35 pounds. The second bypass valve leads through with one or two of the large oil filters from the back to the crankcase of the engine. 53. The crankcase can be drained oil clear with the accumulation water opening with a globe valve in the drain pipe of the drain pipe to the left side of the locomotive below the bed with the use of the cap at the end of the drain pipe. It protects against the loss of oil from the unauthorized accidental opening of this valve. 54. Lubricating oil pressure gauge instrument and panel indicate the pressure lubricating oil between the Kuno strain of the engine. This same pipe leads the oil pressure switch with the connectivity electrically with the engine governor shutdown solenoid. Oil pressure switch operates if the oil pressure drops below 20 pounds. The operation of this switch opens the electrical circuit which calls for the governor to shut down the engine. 55. It is desirable to handle the Kuno filter can be turned every 4 hours to keep the filter surface clear of any of the sludge of the accumulating from the oil. 56. Check if anything loose for the under repair. With a carefully operator will check for the last work of the report to find out what repairs, if any, were listed, what will work, if any of it done with the power plant, with the locomotive during the layover. With this information, a special inspection of the engine trucks can be made to ensure that the work listed has been completed. 57. Serious damage may result in tools blocking anything else that has been left loose in the engine compartment. If the engine is started before the repairs have been completed, before pushing the start button for the start of the engine, inspection should be made to see that cylinder head covers that are in place and the belts and the belt guards, etc. are in place, that there are no loose tools laying on the engine auxiliary equipment. 58. If the inspection cover over the opening of the above the brush, if any of the traction motor is not in place, it is likely that the motor will heat. Cooling air delivered with the motor of the traction motor blower will escape without properly serving its purposes. The loose cover will also moisture with the dirt enter the motor case. This might cause the ground related chip. 59. Check position, ventilators and shutters. Before starting with the engine, check should be made to see that the shutters of the oil section side of the radiator of the proper position. The shutter at other sides of the locomotive, the left side should be adjusted in accordance with the weather. Operating requirements: shutter lever in the cab regulates the shutter opening of the fan, the roof hood of the engine. The fan shutters open when the lever is forward and closed when the lever is back. Shutter must be adjusted to maintain a cooling water temperature between 150 and 170 degrees. 60. Shutters on the radiators can be left closed in the cold weather until the engine warms up. In case the engine cooling water temperature gauge in the cab must be watched closely. 61. Check the fuse panel to make sure that all the fuses are in place for the main fuse panel with the switch box on the side of the instrument panel with the lower E15 figure 11 leading to the fuse is shown in figure 16. Each fuse is opposite of the corresponding switch. 62. There are 4 other fuses to be checked. They are left on the door of the electron cab. 3 of them can be seen in figure 17. 4 from the top of the bottom of the compartment: light fuse, the auxiliary generator fuse, the auxiliary generator fuse, and the main battery fuse. The fuse position should be inspected. See that all fuses are in place. Apply extra fuse to each of the different types that should be handed in some suitable storage receptacle. The inspection fuse panel should be include a check to make sure that certain that there are extra fuses all needed size of the hand. 64. It is not required to turn an American Locomotive Company diesel engine over by hand to check for the accumulation of water of the oil in the cylinder. Such accumulation seldom occurs. Should there be any noise, the first cranking of the engine, they might indicate water or oil in the cylinders. Cranking should be stopped instantaneously. There is a plug near the bottom of the head of each cylinder that can be removed to clear the cylinder. Starting the engine. 65. To start with the engine, refer to figures 11 and 12 with the folder insert with the back of the tach. See if the handbrake is set unless the pressure of the air brake system. 2. See that throttle A is lashed into the idling position and forward stop is in position against the forward stop is shown in figure 11. See the reverser hander B is in its mid-neutral position. Stands in figure 11. 4. Close with the main battery switch handle. K with the figure 12 switch is closed with the handle with the clear forward. It opens the handle, is pulled by the clear back. 5. Pushing the control switch E2. Pushing the fuel pump switch E3. When the fuel pump is started with the root run sufficiently so the hand of the fuel oil pressure gauge figure 5.4 show that about 35 pounds the engine is ready to start. 66. Not now, but not until now. Pressure on the engine of the start switch E1. Hold it in. The engine should turn over immediately with the may fire during the first revolution over its warmth. In the event that it should fire by the time the engine reaches approximately 200 revolutions per minute, but it should be within 3 to 4 seconds. 67. When the engine fire, do not release the starting switch. The switch must be held until the hand of the lubricating oil gauge F6 shows the validity more than 20 pounds of pressure. Otherwise, the engine will shut down automatically by the action of the low oil pressure switch. 68. If the lubricating oil pressure does not build up properly within a very few seconds after the engine fire, the starting switch should be released so that the low oil pressure will stop the engine. Then reason why the oil pressure does not build up in the max must be discovered and corrected. 69. If the engine does not fire before the cranking speed reaches 200 revolutions per minute within 3 to 4 seconds, the starting switch should be released. The cranking should be stopped until the cause of the failure to start is certain. 70. The engine start switch should not be pressed and the release then pressed again as it is done at times of starting an automobile. This would cause an arcing electrical contacts which might melt weld them and cause the engine failure. The starting switch should be pushed and held in until the engine fires and has been built up on proper lubricating oil pressure until the apparent that there is some difficulty which must be corrected before engine will fire. 71. The engine fails to start. The failure of the engine starts may be because the engine does not turn over because it turns over but will not fire. 72. Engine does not fire and does not turn over. This means the power of the battery is not reaching the generator sufficient force to cause the run of the motor. 2. With the crank the engine with the triangle locate the cause of this trouble. Start all over again to see if the reverser handle throttle switches are in correct position. Something may have been overlooked or forgotten. 73. If the main battery switch is closed, see that the battery fuse of the electrical cabinet is in place. It may be that the fuse is blown and try any another one from the spare style, but do not throw away the one removed. It will be alright. Something else might be wrong. Check if the control switch fuse E2 for the engine starting switch E1. Replace them with spares to see if that they are blown. 74. If the fuse are alright, it may be that the battery is too weak to turn the engine over. Open the door, electrical cabinet, watch the starting contactors while someone pushes the engine start switch. Have the electrical contact engine compartment lights turned on when you make the first test. If the contactors pull in but the lights go dim, that they can hardly be seen to indicate the battery is too weak. 75. If starting with the contactors do not pull in when making the test of the battery may be alright, it takes the two sticks of the wood, such as a hammer, handles, and flagstaff. Place one against each of the contactor. The contactors carry only battery volts of 64 volts. There is no danger. Push in hard. Both contactors hold them in firmly. If the engine cranks, continue to hold in on the contactors until the engine fires. The oil pressure builds up to be 20 pounds. If you hold the contactors with only a light pressure, arcing may occur, which will be bright enough to hurt your eyes. Keeping your eyes closed and turn your head away. When you let go, do so with the both sticks at once. Do it quicker the movement as not to draw an arc. These contactors contain a magnetic blowout that will always cause a loud pop when the contactors open quickly. 76. There's another possibility. Someone at the shop may have put wedges of the wood starting with the contactor to prevent accidental starting of the engine while this is being worked on. Wedges may have then forgotten left on the contactors, so if they show a sticking out of the arc chute for the top of the contactors, brand of course, is to remove them. Pull the battery switch open first. Do not forget to close it again. In this case, very sure that all the work has been completed on the engine so that it may be started without damage. 77. The engine rotates but does not fire. There are two things that can be kept in mind firing the diesel engine. 1. Atomized fuel must reach the cylinders. 2. There must be a sufficient compression so that the air compressed above the piston will be hot enough to ignite the fuel. 78. Check the fuel pressure. If the pressure show of the fuel oil gauge F4 of the main fuel pump motor is running. If so, the coupling between the motor and the pump is all right. The motor is not running. Check the fuel pump switch or the E3 fuse. Try another fuse next to recheck with the fuel supply of the fuel oil tank. Recheck the position emergency fuel cutoff valve. The valve is closed and this has to be reset and latched by hand. 79. If the trouble has not been found, check with the engine overspeed trip. Make sure that there's running position. That might be trouble with the electrical circuit, but the governor solid solenoid might stuck with trouble. The governor pistons would not rise. If so, no fuel would be supplied to the injectors. The light tap on the solenoid might cause the correct the difficulty. Also, there might be air in the fuel oil pipes at the plunger pumps on or in the ejectors. Cranking the engine may clear the fuel oil lines of the air. If not, the air will have to be bled out before the fuel can reach the cylinders. 80. When mechanical throttle linkage, there is a possibility the pin may have dropped out, that the linkage may have become jammed, or that the linkage may be icebound in winter weather. 81. Low compression. The only thing that might lower the compression in the engine that otherwise is alright, but would be the removal of the cylinder test plugs, and escape of the air from the test plugs opening will be heard when the engine is being cranked. The plugs should be replaced if they are out. Before moving the locomotive. 82. After the engine has been started, lubricating oil pressure has built up satisfactory. Following checks are necessary before the locomotive is moved. A. Check with the air supply with the main reservoirs and the control reservoir with the main reservoir pressure indicated with the red hand on the gauge. Figure F1 on figure 11. The control air reservoir pressure is indicated by hand on a control air gauge. Figure F5, figure 11. Must be sufficient main air reservoir pressure to operate the brakes, and control reservoir pressure is less than 70 pounds, but the contactor will not operate properly. The time should allow the air compressor to raise the pressure to 70 pounds. B. The check with the engine cooling water temperature gauges should indicate at least 125 degrees before any attempt is made to move with a heavy load. 83. The locomotive cannot be moved if the ground protective relay contacts are open. The relay shown in figure 21 and figure 18. There's a red fiber latch at the top of this relay. The relay is reset lifting the latch. When the latch is lifted, the contacts will close. The locomotive can be started. However, the ground relay may be tripped again when the locomotive is started. The circuit will be broken a second time if the ground still exists, in which may, when making a routine inspection prior to starting the locomotive as well, to make certain that the armature of the ground relay is not latched with contacts open. 84. There are certain safety precautions that always should be taken before moving the locomotive that has been shut down, has been standing any length of the time of the first precaution. Make sure that there is not only no one working underneath the locomotive that is not blocked with any of the manner. Equal importance with the test air brakes to make certain that there is sufficient air pressure and then the brakes operate properly. If the engine has been out of service for some time, the operator should make certain that the bell and the whistle both operate and the standards work properly, and that the headlight will light, etc. 85. To move the locomotive, complete the instruction for operating the Alco GE switching locomotives are contained in unit number 223A. 86. Stop. The stop of the locomotive, return the throttle to idle position, apply with the air brakes gradually unless the emergency action is necessary. Do not move the reverser handle until the locomotive has come to a full stop. Shutting down of the power plant. 87. The proper way to shut down the power plant is to open the fuel pump switch in the cab. This will cause the fuel pump to stop. Opening the switch also opens the circuit to the governor solenoid, so the solenoid will dump the oil pressure at the governor, and the shutoff supply with the fuel oil for the boss plunger pumps with the fuel injector and nozzles. 88. If the engine has been working hard just before the time shutdown, it should be allowed to idle for about 5 minutes to let the temperature equalize throughout the engine block cylinder heads. In cold weather, all shutters should be closed when the engine is shut down. Of course, the water must be drained from the cooling system if the engine is shut down outdoors in freezing weather. 89. If the crew leave the locomotive after shutting down the engine, the air brake should be released when the handbrake set, but the all switch should be open, including the main battery switch. The reverser handle should be removed from the stand but left on the locomotive. 90. Starting and stopping the engine with the older Alco GE switching locomotives. On some earlier Alco GE switching locomotive, three-way valve located at the right side of the control stand is used for starting and stopping the diesel engine. This valve is exactly like a standard valve to start with the diesel engine. The handle of the valve is placed in the vertical position, after which the engine start button is pressed and held in. When the engine starts, fired lubricating oil pressure has built up to 30 pounds. The handling of the three-way valve should be removed to the running position. 91. The handle of the valve never should be left in the starting position while the engine is running because of the low lubricating oil. Automatic shutdown is imperative. In this position, the diesel engine always must be stopped by moving the handle and the three-way valve to stop position. Engine equipped with the valve never should be shut down by opening the fuel pump switch. Should this be done, the engine would not stop until the fuel lines are pumped dry of oil. Miscellaneous. 92. For the proper idling speed of the engine is 275 revolutions per minute. Terminal manufacturer maintainers have an instrument measuring engine speed of the engine sound as over the idling too slowly or too fast. The information should be known. Work report. The operator usually can count revolutions by holding a finger at the bend of one of the pipes from the plunger pumps to the fuel nozzle. There will be one pulse for every 2 revolutions of the crankshaft over the engine. The engine speed will be twice the number of the pulses per minute. 93. Reverser handle shaft is interlocked electrically for the throttle with the control switch closed. Electrical connections which cause the traction motor to reverse cannot be changed in the movement of the reverser handle and while throttle is open. 94. If the throttle is pulled away from the idling position to move the locomotive does not start with move it immediately. For any reason, the throttle should move back to the idle position. If the throttle is left out with the current flow for the motors will move the for the locomotive. The motors will heat, but may be damaged in short time. 95. Of the field circuits of the Alco GE diesel generators are energized by exciter. Exciter is combined with the auxiliary generator. This explained with a further section electrical action of other texts. Traction motors of these locomotives are cooled by passing current over the air through the suitable passages in the motors. The current air is supplied by the 2 traction motor below. The auxiliaries are located within the engine compartment of the locomotive. There is one for each truck. 97. The individual set of the V belt drive for engine and auxiliary generator excited with the 2 traction motor blowers. The gear set with the turns of the radiator cooling fan. Each set of belts should have sufficient tension over the drive, the auxiliary properly with the belt coverage safe for the guard that should be in place. 98. A dump valve of the governor power cylinder is held close to the electrical solenoid. Circuit tube of the solenoid is open, but it happens when the fuel pump switch is capped open. Dump valve of the governor is opened with the lubricating oil pressure arm. The underside of the governor power piston is released. Spring over the governor then operates to do a force so that the plunger pump and control shaft of the flush injection assembly into a shutdown position at the stop of the engine. 99. A turbocharger application using the Alco diesel engine is named the Bushi for its inventor. It consists of a small gas turbine directly connected to the centrifugal blower. After the diesel engine is started, the exhaust gas is passed through the drive of the turbine with the turbocharger on their way to the atmosphere. The operation of the turbo causes a and then we'll come back for those pictures. Centrifugal blower supplied with the intake manifold of the diesel engine at pressure of around 5 pounds per square inch has been stayed with compressed air with the heat to help scavenge exhaust gas from the cylinder of the diesel engine to supercharge the cylinders on with the air each compression stroke. 100. The additional of the turbocharger of the diesel engine requires the very careful readjustment of the timing both the exhaust and emission valves and when the engine emission valve to open during the exhaust stroke to help excavate the cylinder of the exhaust valve to close until the piston has reached the top of the exhaust stroke and started down again with the intake valve to not close and closed until the piston reaches the bottom of the emission stroke. 101. If the unusual noise should have developed in the turbocharger for any reason, the engine should be shut down at once. This way, There is a way of blocking the turbocharger unit if it has been kept from running. If the turbocharger unit is blocked with a diesel engine, can be restarted, can be restarted and operated, but the power of the engine will be reduced because of the elimination of the turbocharger feature. Lubricating engineers. Locomotive engineers assigned to running the diesel locomotive, which are equipped with a turbocharger, should find out from the maintenance force how turbochargers may be blocked. Electrical cabinet 102. For the figure 17 and 18, two views locating electrical cabinet, different angle of the doors of the cabinet were removed for the purpose of taking a photograph of the names of some of the items of the electrical equipment that are listed below the side of the illustration. The location of the 4 feet of the electrical cabinet is shown in figure 17. Starting contactors shown in figure 18. Location ground relay also shown in figure 18. Explanation electrical apparatus and the circuits are given in later text. Alright, the 66 horsepower switcher. 103. It has been stated that the practical no difference for the operation power plant of the 660 horsepower switcher than the 1000 horsepower switcher. The absence of the turbocharged 660 horsepower switcher makes no difference in starting, running, or shutting down the power plant. The road switcher 104. There's little apparent difference for the starting and running shutdown of the power plant, but the road switcher already has described on some of the road switcher with the reverse handle at the top of the instrument plunge panel alongside with the throttle chamber that makes no difference to operating power plant, but they are not to throttle some of the road switchers and corresponding electrical controls of the engine. Again, however, there is no practical effect for the method of the starting, running, and shutting down of the power plant. Examination questions, and then a half a picture, some more pictures, a half a picture, and that completes Railway Education Bureau Stop, Think, Study, Gears, Road to Success Instruction Paper, Unit Number 22A, Diesel Locomotive Operation Power Plants, Alco GE 660, 1000 horsepower diesel locomotive subject. Copyrighted 1948 by D.C. Buell.